friends, I'm Pavitra Kumbargad. Welcome to my channel. So in this session, we will solve the problems on Leibnitz Rule. Okay. So actually Leibnitz Rule is for the finding the nth derivative of product of two functions. So in the standard nth derivative of standard functions, you have only the product of exponential and the trigonometric function, that is e to the power of ax sin bx plus c and e to the power of ax plus into cos bx plus c. So here we have a general formula for product of two functions. So Leibniz rule states that if we consider two functions, that is u and v are any two functions of x, then the nth derivative of u and v is written as u vn. So first you find the nth derivative of v. So u into vn plus nc1, that is binomial coefficient, then first derivative of u and n minus 1th derivative of v. So plus nc2, the second derivative of u, then n minus 2th derivative of v, and so on, plus ncn minus 1, u n minus 1th derivative of u and first derivative of v, plus ncn is 1, that's why I have not written here, nth derivative of u and first no derivative here, v into v. So that means you have to go on, means in the increasing order, nth derivative of v, n minus 1th derivative of v, n minus 2th derivative of v, and so on. And for a u function, no derivative here, first derivative, second derivative, and so on. For one function you have to go on increasing order and another function in terms of decreasing order with the binomial coefficient. So here you should remember, you know this, nc1 is n, nc2 is n into n minus 1 divided by 2 factorial, nc3 is n into n minus 1, n minus 2 divided by 3 factorial, so on. Okay, so we'll solve some problems on the nth derivative of product of two functions. So here I have considered the two problems. First one is x cube 4 raised to x, simple problems. First we'll solve the simple problem. So given function, take it as a y is equal to, right, the given function as y is equal to, solution, first one a, y is equal to x cube into 4 raised to x. So here what I will do here, so x cube, so the derivative, after some derivative it will become 0, the polynomial especially. So I will take polynomial as a first function here. Okay, so that means it will, after some derivatives it will become 0. So u I will consider as a x cube and 4 raised to x as v here. So directly we will write here yn is equal to, first x cube as it is, means first function u as it is, nth derivative of 4 raised to x. So you know the nth derivative of a raised to mx, right, m into log a whole raised to n 4 raised to x, right. So here a is 4 here, m is 1. So 1 into, so log 4, correct, raised to n into 4 raised to x. So this is the nth derivative, plus nc1 is n into first derivative of x cube. X cube derivative is 3 into x square, then n minus 1. So in place of n you should write n minus 1. So that is log 4 raised to n minus 1 into 4 raised to x, plus, Now NC2 is n into n minus 1 divided by 2 factorial is 2. So next derivative, x cube first derivative is 3x square. Next derivative is 6x into n minus 2. So that is log 4 raised to n minus 2, 4 raised to x plus NC3. NC3 is n into n minus 1 into n minus 2 divided by 3 factorial is 6 into 6 differentiation. Next derivative is 6. Then n minus 3. So that is log 4 raised to n minus 3, 4 raised to x. So the next derivative, the differentiation of 6 becomes 0. So you should stop it here. Entire term becomes 0 for the higher next terms. So therefore, nth derivative of x cube 4 raised to x is this. Now move on to the next problem, B. So here the second problem, B. So that is y is equal to e to the power of minus x square sine hyperbolic 2x. First what I will do, sine hyperbolic 2x formula you apply, then multiply, then apply the nth derivative. So that is equal to e to the power of minus x as it is I will write, and x square also as it is. Sine hyperbolic x formula is e to the power of 2x minus e to the power of minus 2x divided by 2. Now multiply these two. So 1 by 2 you take common. So x square e to the power of minus x, e to the power of 2x is e to the power of x, right? 2x minus x is x, minus e to the power of minus 2 x square into e to the power of minus x, e to the power of minus 2x is e to the power of minus 3x. Now apply the nth derivative. So that is yn is equal to, so 1 by 2 as it is. So first function x square as it is, nth derivative of e power x is e power x, plus nc1 is n, x square differentiation is 2x, nth derivative of e power x is again e power x, plus nc2 n into n minus 1 divided by 2 factorial is 2, correct? Then differentiation of 2x is 2 into e power x, plus next differentiation of 2 becomes 0. Now then this minus sign is there, so therefore I will write a minus into bracket, you should write, okay. Okay, so minus, so use one bracket here because minus sign applies for everything. So x square as it is, differentiation of e to the power of minus 3x, that is minus 3 whole raised to n e to the power of minus 3x, right? Then plus n into x square differentiation is 2x, so n minus 1 the derivative minus 3 raised to n minus 1, I should write n minus 1 here, sorry, I have written, okay, so that is n minus 1, n minus 1 e to the power of minus 3x, so one more term comes, plus n into n minus 1 divided by 2 factorial is 2, right? So differentiation of 2x is 2, minus 3 whole raised to n minus 2 the derivative it is e raised to minus 3x, so close both the brackets. So this is the nth derivative of e raised to minus x square sine hyperbolic 2x. These two simple problems I have taken it as a how to apply the Leibnitz rule. Okay, so one function usually you take as a polynomial as a first function, second function another function you take it as a second function, then apply the nth derivative. So these two are the simple problems. So now move on to the standard problems. These type of problems usually they will ask in the examination. So the second problem is, if y is equal to a cos log x plus b sin log x, then show that this term and also apply the Leibniz rule to find the nth derivative. Okay, so first, so take the given function y is equal to, the solution is given function y is equal to a cos log x, right, plus b sin log x. So here the term which we want to show, it contains second derivative, right? So you have to find out up to second derivative. So differentiate two times. So first derivative you will get y1 is equal to, you have to apply here what? Chain rule. So a is constant, differentiation of cos is minus sign, right? Minus sign log x. Minus sin log x into differentiation of log x is 1 by x, correct? Then plus b as it is, differentiation of sin is cos log x into differentiation of log x is 1 by x. 1 by x, 1 by x is common, right? I can take it as this side, so that you will get x into y1, x into y1 is equal to minus a sin log x plus b cos log x, right? This is the first derivative. Now find out the second derivative. So here x is function of x, y1 is also function of x, right? So you have to apply the product rule here. So what I will do, product rule, apply the product rule, x as it is, what is the differentiation of y1? Differentiation of y1 becomes y2 plus y1 as it is, differentiation of x with respect to x is 1. So y1. So that is equal to minus a is constant. What is the differentiation of sin? That is cos. Cos log x into differentiation of log x is 1 by x plus b as it is, differentiation of cos is minus sin log x into differentiation of log x is 1 by x. So 1 by x, 1 by x again common. So that will be x into xy2 plus y1 is equal to, so in the both the side minus sign you can take it common, minus sign a cos log x, right, plus b sin log x. So you can observe here, what is a cos log x plus b sin log x? That is y. So you can replace it. So multiply these two. So what you will get? X square y2. So this is x square y2 plus x into y1 is equal to minus this term becomes y here. This y you take this side. So that will be x square y2 plus xy1 plus y is equal to 0. So this is our required result here. So x square y2 plus xy1 plus y is equal to 0. Now apply the nth derivative formula. So same as we have applied in the previous problem. So here take polynomial as a first function, right? So here x square as it is, what is the nth? Already we have differentiated 2 times, right? Again n more times I have to differentiate. So nth derivative is yn plus 2, correct? y2 means second derivative. So y3 third derivative. So if you again y2 already is there, now again n more time I have differentiated. So therefore it is yn plus 2 plus nc1. nc1 is n, differentiation of x square is 2x, then n minus 1th derivative. So add this 2 plus n minus 1. So that is yn plus 1. Then plus nc2. So that is n into n minus 1 divided by 2 factorial is 2. Correct. Differentiation of 2x is 2. Then n minus 2th derivative y2 plus n minus 2. 2 to get cancelled, it will be yn. yn. Correct? This is the next differentiation becomes 0 plus next term x as it is. So nth derivative of y1 is yn plus 1 plus nc1 is n, differentiation of x is 1, then n minus 1th derivative is of y1 is n, because 1 plus n minus 1 plus 1 get cancelled, yn plus differentiation of y n times means yn, so that is equal to 0. This differentiation of n time of y is yn. So now simplify this, you will get the nth derivative. So first x square into yn plus 2 plus, so take yn plus 1th term. So this is yn plus 1th term and this is yn plus 1th term. So take it common. So x is also common here. X into, right, 2n, right, plus 1 into yn plus 1. So take the common in these two. Now yn term. So this is yn term, this is also yn term, and this is also yn term. So that is plus. So here 2 get cancelled. So multiply n here, n square minus n. So this is plus n and plus 1 into yn is equal to 0. Plus n minus n get cancelled. So one more step I can write here. So that is x square yn plus 2 plus x into 2n plus 1 yn plus 1 plus n square plus 1 yn is equal to 0. So this is the nth derivative of the given function. So see here y they have given, you have to differentiate 2 times, then apply the Leibnitz rule, then simplify, you will get the nth derivative. These type of problems are very, very important in the examination. So I'll take the one more problem here. Y is equal to sine inverse x, then prove this. So write the given function as y is equal to sine inverse x. So the given, prove that, you should see here yn plus 2, highest term plus 2 is there. So therefore to find the nth derivative of y2, so you have to differentiate 2 times. So differentiate 2 times this function. So y1, first derivative y1 is equal, you know the differentiation of sine inverse, so that is 1 divided by root of 1 minus x square, right? So if you want, you can apply the cross product. So that is root of 1 minus x square into y1 is equal to 0. Right? Otherwise you can directly also you can differentiate. So here apply the product rule. So first root of 1 minus x square as it is, differentiation of y1 is y2 plus y1 as it is, what is the differentiation of root x? 1 divided by 2 root x, right? 1 divided by 2 root 1 minus x square into, apply the product rule, 1 minus x square for differentiation is minus 2x. So that is equal to 0, right? Now 2 get cancelled. Take the LCM, root of 1 minus x square is LCM, so that will be 1 minus x square y2 minus x y1 is equal to 0, right? Now apply the nth derivative. So the first term, 1 minus x square as it is, nth derivative of y2 is y n plus 2 plus nc1 is n, differentiation of 1 minus 2x square is minus 2x, n minus 1 the derivative is yn plus 1 plus nc2 is n into n minus 1 divided by 2 factorial is 2, differentiation of minus 2x is minus 2, n minus 2 derivative is yn, correct? Then minus, so minus sign is for every term here, so use the bracket. So x as it is, nth derivative of y1 is yn plus 1, correct, plus n into first derivative is x, yn. So that is equal to 0. Now take the terms, common terms. So 1 minus x square into yn plus 2, right, then yn plus 1th term. So plus I will write, so this is minus 2n x, right? X also I can take common. So this is this term and this term contains x also. So therefore I will take x also common here, and minus sign, both the terms also contains minus sign also. So take minus sign also. I will write once again please. So that will be minus x is common. So the first term yn plus 1 also I will take common. So and this term becomes 1, right? N plus 1 y n plus 1. Then here 2 get cancelled, and this term also minus sign is common, minus, right? So into bracket n into n is n square. You can take n also common here. Okay, no problem. N square minus n plus n, right, into y. Okay, so plus n minus n get cancelled. So therefore that is equal to 0. I should write equal to 0. One more step I will write, 1 minus x square y n plus 2 minus x into n plus 1 y n plus 1 minus n square yn is equal to 0. Let me check the solution, is the same or not. 1 minus x square n plus 2 minus 2n plus 1. See here, 2 I have missed here, correct? 2x, 2 is there. So this is 2n, right. So this is 2n and this is also 2n. 2n plus 1 x yn plus 1 minus n square yn. So this is the solution. Okay. So thank you for watching. Okay. Thank you for watching. So please like, share, comment and subscribe to my channel. So thank you so much. Bye bye.